Good afternoon. My name is Roderick. I'm heading CERN's Controls Software and Services Group. We're responsible for the control and monitoring solutions for CERN's accelerator complex, also the transfer lines between the accelerators and the experimental areas, as well as some supporting technical infrastructure. We're giving some remote controls, obviously, to operations teams and equipment experts, Beamline specialists, and so on. And one of our key aims is to give something that's as simple as possible to use, stable, available, and we try to apply a common approach. So we want this kind of all-in-one remote control. However, this all-in-one remote control is for the accelerators only. So when it comes to the fixed target beamlines, it's not the case. And that's kind of the focus of my talk. So CERN is well known, especially in sort of the last 15 years, for the LHC, the Higgs discovery, and the big experiments there like ATLAS and CMS. However, we have two fixed target experimental areas, which you can see on the slide. Is there a point? Yeah, okay. So we have a north area with around 2,000 users coming every year to work on the various beamlines we have here, and the east area. They're both really old. The east area has been recently refurbished a couple of years ago, and the north area is foreseen to be refurbished in the upcoming years. I would say, okay, there's about 8 kilometers of beamline with 10 beamlines, and then many experiments. You can find more information here about the various experiments that are set up. So to set a little bit the context of the rest of the presentation, I wanted to share with you some of the challenges we're facing, and these are general challenges, and I guess you can mostly, if not all of you, identify with them. So we can see a growing scope of controls activities over time, growing number of requests, pressures, whether it's data volumes or cybersecurity, and expectations. I mean, we've been hearing about AI and ML, and people, I want AI, I want ML. They don't always know what they want it for, but they want it. Also a growth in languages. So, okay, we can go C++ down at the real-time level, Java, but then with AI and ML, not only, but in general, we see big growth in Python. But where do you want to use Python? Do you want to use it for data analysis, or you want to use it for everything? And okay, I realize many of you have Python-centric systems, and traditionally at CERN, we have a lot of Java. But so this is something new for us. And of course, lots and lots of data. We also have to face growing technical debt. We're lucky that we have a fixed dimension workforce. We would be luckier if it was scope for it to grow. But we also have to face retirements, and sometimes the people leaving are taking away a lot of knowledge and expertise and commitment, and it's not always easy to replace them. Sometimes it's the other way around. People are leaving, and we say, oh, finally we can change the system. But then if we move on to the experimental areas, so we've got the east area and the north area, we have some challenges which are specific to those areas. So beamlines are regularly reconfigured, every Wednesday to be precise. As I said, beamlines in the facilities are old and in need of consolidation, and there are not really any synergies that are being exploited between operations of the accelerators and the beamlines. It's different teams, they don't have common practices or anything like this. So the beamline physicists are really stretched as well, dealing with everything in the middle. So we kind of have a quest for increased efficiency, and the powers that be said, well, let's just use the accelerator software solutions for the experimental areas. Then we've only got one approach, and yeah, this will be easy and it will solve all of our problems. So we're on a journey to get there. But first, let's go back a couple of years ago, and this is what we have. to a large degree, we still have this, but I'll update you on that. So we have a dedicated full-stack control system. It happens to be called Caesar. When you see links, in case you're interested to know more, it's usually a link to a paper, Ecolab's paper or something like that. As I said, we're Java-centric, so this is quite old Java 2 Enterprise Edition software in the server here. We've device logic, access control, got a dedicated configuration database where we integrate logic as well about optics. We've got a user interface, which is all-inclusive for everybody, so Beamline experts, Beamline users, don't touch this, don't touch that, and so on. And this is based on NetBeans, and we're completely stuck with Java 8 on this, which also becomes a concern when you need to upgrade the operating system, cybersecurity, et cetera, Overall, this works quite well for the users, but nevertheless, it's expensive and difficult to support and to upgrade. So some of the things we're doing, I would mention first of all fault tracking. So we've taken our accelerator fault tracking system, which was originally developed for the LHC. It's now spread throughout the complex, and we're using this to capture faults, so to record faults and their impact on different beamlines, destinations, and so on, and have regular, easy access to information about what's going on, what's failing, etc. This is integrated with our electronics logbooks, our layout system, and schedule management systems, which I'll mention in a moment. And it's all built using what is a standard technology stack for us. So that's Java servers based on the Spring framework, web-based UIs using the Angular framework with Material, Oracle databases for persistency, and REST-based inter-service communications. So this really facilitates the regular communication on operations performance in sync with accelerator operations, and it serves as a basis for understanding the issues that come up and their impact over time. So then this is used to consolidate the experimental areas and to justify we need money to replace these power converters, etc., etc. Moving on, schedule management. So we've extended our accelerator schedule management system to the experimental areas. So first, just to say a few words about what that is. So it's the system that exists has a scope that covers the accelerator schedules, controls upgrades, and machine development planning. So we have accelerator schedules, what's going on, when. We have in here controls upgrades. So at certain times when there's upgrades, everything is done in a coordinated way, validated by operations team, etc. So there are no surprises and downtime due to controls changes. And we manage the machine development planning. So users submit requests for machine development time, coordinators schedule that and have the overview, and over time we have statistics on who's got beam time, etc. So bringing that to our experimental areas, okay, here I mentioned as well, there's an API for this system to integrate with other tools. So for example, our archive data extraction. So let's say you want to have a look what was going on, but only during your machine development period or only during operations time. Same thing for fault tracking. You only want to know the availability during the time that you're interested in. So bringing this to the experimental areas was driven by a situation where beam time management was complex and time consuming. So thinking about the time taken to prepare everything, and okay, this is the workflow that was in place. So a lot of emails, Word files, Excel files, SharePoint sites, and so on. So we brought all of this together into what is now a much more coordinated approach with experiment planning, detailed requests, exchanges on the requests, all centralized between different coordinators, task schedules, so what needs to be where, so for example, what needs to be where and when. So for example, tables where they need to be at a certain time, etc., etc. And again, this is the same technology stack that I've already mentioned. Next up is our layout system. So this is a centralized platform to manage the physical configuration of the CERN facilities over time. So there are different aspects to this, but with this you can get answers to questions like, well, what is installed? Where is it installed? When was it installed? What does it interface with? And okay, it's integrated with many systems. So we have a concept of functional positions. So it's not the assets, right? It's not the asset management, it's the functional position. What type of equipment should be there? What function does it play? How things are connected? Where they're really positioned precisely? And domain-specific data, which can be many different aspects. So for example, optics associated with beamline elements and so on. And we manage this over time, so we can go back in time, but we also go forward in time, and you can have multiple parallel versions, which allows you to plan different scenarios for the future. So for the experimental areas, what we had to do was add support for weekly versions. As I said, the beamlines get reconfigured every week. And this allows us to automatically generate MADEX sequence files, which are then used in turn for optics generation. So we can see examples of sequence files here, and also like see easily the changes in those over time. We also developed data-driven schematics, replacing handmade drawings like here. And so you have data-driven schematics for the layout every week and comparison functionality to see what things were over time. This also allows users that are coming back to be able to say, but what was my configuration 2 years ago, something like that. Moving on, same technology stack, but moving on to control. So last area I wanted to mention. So as I said, we're aiming for accelerator control subsystems to be adapted to meet the experimental area's needs. And what we expect is that this will lower the technical costs. It will facilitate collaboration with accelerator operations and will also increase operational capabilities. So as a simple example of capabilities, we have a concept of high-level parameters. So in an accelerator, for example, what tune do you want in the machine? In the experimental areas, it would be to say, well, what is our target alignment position, rather than tuning individual magnet currents, etc. So we're going to be adding on our, well, we've actually already done this, put our settings management system in place, which allows us to replace the legacy settings management approach, also parts of the expert user interface. We put in place our controls configuration service, our kind of virtual device service, or a little bit like function as a service, but a platform for logic. Also related to sequences of logic, we have a sequencer. And last but not least, we have a GUI, which is highly configurable based on web technologies and drag and drop configurations, so zero code. So that brings me back to meeting the needs. We have this mixed user base, like all institutes, and the GUI must be intuitive and tailored to the users. So for this, as I've said, we're using RAP, but we're also going to be combining this with an evolution of the layout-based schematics towards having interactive synoptic controls, so something fully integrated, generating the controls based off the weekly changes without anybody having to write any code. Or at least that's the idea. So I'll tell you at the end of next year if it worked. So to summarize, we're aiming to increase the efficiency, lower costs, and address technical debt, as well as improve the user experience associated with the CERN's fixed target experimental areas. To do this, the software is being expanded and streamlined with the accelerator control software. Along the way, we're establishing a digital thread that goes from planning to installation to operation and maintenance. Fault tracking, scheduling, and planning are already very well established, as well as optics generation. And development is ongoing to replace the legacy standalone control system in the coming year. That's it. Thank you very much.
Okay, again, one question and then we move on.
It sounds very ambitious. Thanks. Has this also been used to reduce the staff, or have you actually been able to keep the same staff?
For now, we managed to keep the staff. I've not seen any reductions coming up as a result of this, but more that we will be able to properly contain risks and answer to new requests with the same workforce. A little bit the same on the AI/ML front. We've heard a few people talking about AI-based assistance, automated control. I haven't mentioned it here, but in general, that's something we're also actively working on. And the reason is the same thing. It's not to reduce posts, it's to repurpose people to do other more valuable things, hopefully.
Okay, thank you very much. Let's thank Chris again.